Okay, good morning, welcome back. Hope we had a great weekend. Today, February 21st, we are finishing lesson 8 and doing all of lesson 9. So we'll just remind you, lesson 8 is highlighted in this top row here, lines of best fit. We did the demo for this thing last time. What was the example? It was about deaths due to car accidents and what percentage of those deaths were attributed to drunk driving. That was the example that we talked about last time. And then you started the activity with some question about x-rays. And I think a bunch of folks made some good progress on that question. So we'll give you time to finish those activities today. And then we'll also do all of section 9, which you see as a supplemental section. And it's called In Context Linear Problems. Coming up in the not too distant future is quest number 2. It's not this coming class, but it's the one after. So 1 week from today is our second quest. And that quest is going to be on lessons 6 through 9. 6, 7, 8, and 9. So once we finish today, that's the end of the material for the quest. On Thursday, we are going to cover 10 and start 11, but those sections are not on the quest. Any questions on the schedule? Okay, then let's jump in here on page 68. We're going to do things a little bit differently here today. Typically, I would just have you finish the activities from last class, and then we would come together again in a little while and do the demo, and then activities again. We're going to start with the demo from class number 9, and then we'll give you plenty of time to do activities from both 8 and the new section 9. But even before we do that, I want to do this one problem on page 68, this quick check. It says find the equation of the line passing through the point 2, -1, and which is perpendicular to the line y equals 7/3 x plus 14. And the reason that I want to do that, this question together, normally the quick check you do individually, but I want to do this question together because when I walked around last class, I saw that, that some folks were really struggling, not with the perpendicular part, there's really not that much to know about perpendicular and parallel lines, but how do you find the equation of a line when you know a point and you know the slope? And that is a fundamental intermediate algebra process, and some of us don't have it. And I got to be honest, and I got to take part of the blame here because I completely skipped that day. It was one of our snowed out days. And I said, hey, I think this is a review. Go watch my video from last semester. And maybe some of you did, and maybe some of you didn't, but not all of us are where we need to be with that process. And so we're going to do this problem together. Hopefully we'll kind of bring us all into the right spot. So you guys have a bunch of blank space here, whereas I have directions step by step that we're going to follow. But I will tell you, you don't need to go there now. But the directions that I've got here, I just copied and pasted from page 47, okay? So if you're looking for those directions in your packet, you will find them on page 47. But let's see if we can use them to do this problem right here. Okay, so part A says circle both coordinates of a point on the line. We are only given one point on the line. It is that one right there. Okay, so we just circle it. It says if you have 2 points, you can pick either point and circle its coordinates. We just have one. Part B says write down the slope of the line. This is its whole separate process. Write down the slope of a line. If I had given you 2 points to calculate the slope, we use our fancy slope formula, right? Change in y over change in x. But that's not what we have here. We have the word perpendicular. And so you need to know something about perpendicular lines. What can you say about the slopes of 2 lines that are perpendicular? It's reciprocal and also opposite sign, right? 2 things, reciprocal and opposite sign. So let's write that. So this means opposite, reciprocal. Remember, opposite just means different signs. Some people write negative reciprocal, which is totally correct, but I don't like using the word negative there because I think that might imply that the slope you're looking for is always a negative number, but it's not. It's just the opposite sign of whatever the starting slope is. Okay, so in order to find the opposite reciprocal slope, well, we need to know what the slope of the given line is. So this guy right here, we need to know its slope. And fortunately for us, this is already in a very friendly form. Y equals mx plus b. What's the slope of that line? 7/3, right? So it's easy because it's in the right form. And so that means, I'll write this one in red here, the slope of our line, not the green one, but perpendicular, is opposite reciprocal. Opposite meaning negative, and reciprocal meaning 3/7, right? That's the slope of the line that we want. Okay, so that was part B. It says write down the slope of the line. There it is. Part C, easiest step you'll find. Write y equals mx plus b. I can do that. Y equals mx plus b. Just write it. It's really powerful to just write that. It says in the equation above, that is the one that we just wrote, replace the m with the slope and rewrite the entire rest of the equation. So we're copying that whole thing, but we are changing m to what was our slope? -3/7. That goes right there. And you got to copy everything else. That plus b. Some students think like they should be able to just look at everything that's given so far and know the number that is b. But we don't know what b is. We have to do calculations to find b. But a lot of times I see students floundering. They'll say, okay, I know it's a y equals -3/7 x plus, and they'll put a blank there and they'll look around. How come I can't find the b? Well, you can't find it because you don't know it yet. So you just got to call it b. Okay, and then it says, so here's the y equals some number times x plus b. That's what we have right now. And then it says put a star next to that equation. Okay, we can do that. We're going to reference that equation in a little bit. All right, and then part E, it says rewrite the equation from the previous step, but replace the x and y in the equation with the coordinates of the point that you circled in step A. We circled the point. That's an x and a y. Right up there in blue. X is 2, y is -1. We go to the last equation we wrote, and we just change the x to 2 and the y to -1. Just be careful you're putting them in the right spots. Y becomes -1 equals -3/7. X becomes 2 plus b becomes b. It stays as b. That's the thing we're after. And lo and behold, we have enough information now to find b. Another place I see students go wrong is they say, oh, let's see, the b represents the y-intercept, and y is -1, and so they'll put -1 instead of b. Well, yes, it's true, b represents some y-coordinate, but it's just not any old y-coordinate willy-nilly. It's specifically the y-intercept. Is this point right here the y-intercept? 2, -1, it is definitely not the y-intercept. Think about where it lives. Right 2, down 1. It is not on the y-axis. So you don't get to put any y right there. You got to put the specific y, and we don't know it yet. Teresa.
The -3/7, is it a multiplication sign?
Yeah, next to that is a multiplication.
So we round to 100.
We're going to keep fractions, no rounding here. Okay, so we just did part E. It says some number equals some number times some number plus b. Really informal, but this is what our equations are going to look like. And that's what we have right now. And then it's to solve the previous equation for b. We can do that. -1 equals, okay, we'll make this guy a fraction, right? It's really a 2/1. How do we multiply fractions? Diagonals or across? Across, right? It's not diagonals. Let's go straight across. So straight across gives me a -6/7, right? Plus b. We're trying to solve for b. What do we do to both sides? Subtract 6/7. Add it, right? It's already negative, so we add 6/7 to both sides. Let's do the right-hand side. That's easier. What remains on the right? On the right-hand side is just b. Okay, that's good. That's what we're after. Left-hand side, still more fraction arithmetic to do. There's no getting around it. Just off on the side here, you can do -1 plus 6/7. And here we definitely need a lowest common denominator, right? So that -1 becomes -7/7. Oops. So that's a -1/7. Is that okay? Okay, and then last step is part G. It says finally plug this value for B into the equation with the star. We got to go all the way back to the one with the star on it. It's not even on the page anymore. There it is right there, the thing with the purple star. We go back to Y, we go back to X. Those reverted to X and Y again, but we change the B to -1/7, and that's going to be our final answer here. So I'll put Y equals -3/7 X plus, and then actually we'll make it a -1/7. Okay, so there are a lot of steps in that process, and some of us are already really good at that process. I don't need to see you kind of go through. You don't need to circle. You don't need to star. I just try to come up with a process where I could write down, and everybody would be able to follow this process. And with a lot of practice, you can kind of shortcut some of the steps, but definitely take your time if you are not 100% comfortable with that process. Like I mentioned, this is a fundamental intermediate algebra process, and it has nothing to do with perpendicular lines. This question is about perpendicular lines, but I could ask you questions in many different contexts where you need to be able to follow that process, right? Including the stuff we did last class with the x-rays, and including the stuff we're going to do in this next class coming up today, okay? All right, so let's move on to the very next page. Like I said, a little bit different today. We're going to do this demo, and then you'll have time to go back to the previous activities as well as these activities here. Daily summary in this lesson, we use real-world data to find equations of lines. We then use our equations to solve problems. Number one of our rare calculator active problems. According to a report in USA Today, sales for personal breathalyzers have spiked in recent years. The CEO of Wintergreen Research reported that the 2009 personal breathalyzer market was valued at $215 million, up from $28 million in 2005. We will assume that sales are growing at a constant rate and use these figures to predict the value of the personal breathalyzer market in 2015. Okay, let's give this a shot. Part A says define the two variables for this situation, identify which is independent and which is dependent, and we'll, of course, be sure to include units. Okay, two variables in this case. Let's see. I'm going to circle. I've got 2009 was a value of $215 million. And then it says up from 28 million in 2005. So in my mind, I'm starting to group these things together, and I've kind of got 2 points, 2 data points. Each one has an x coordinate and a y coordinate. And so we just have to name the things that these guys are quantifying. So 2009 and 2005, what is that? That is going to be our x. What word what's the quantity? Is time, right? This is time measured in years. Okay, that's good. And then the other one, we'll write that. And then the other one, 215 million and 28 million. What is that? It is measured in dollars, but what is it counting? It's sales, right? It's the value of the breathalyzer market, whatever that means. So we've got time and we got value, and we got to make sure we know which one is which, independent and dependent. If time is involved, it is almost certainly which one? The independent variable. Say it again. If time is involved, it is almost certainly the independent variable. Remember, the independent variable is the one that causes the change in the dependent variable, and time marches on and could care less about the breathalyzer market. But because time is passing, the breathalyzer market is changing, so the breathalyzer market value depends on what year it is. So let's write that in here. We're going to say time in years. You could just say time in years and stop right there. However, if you do that, that means that the first coordinate is going to have an x of 2009, like literally 2009. And so if you imagine x and y axes and going to x equals 2009, where is that? This kind of point? Yeah, where is it? It's way, like way down, right? And so I would prefer not to be plotting points at in the 2000s. You can, but maybe easier would be to start the clock at what year? Maybe the year 2000. That'd be kind of easy. So let's try that. Years since 2000. Years since 2000. That'll make it easier. Okay, and then the dependent variable, don't just say the personal breathalyzer market, but you got to get the word value in there. So we'll say value of the breathalyzer market. And you could just stop there, but we're going to make our life a little bit easier. I'd really like to just put 215 and 28. That's not what these numbers are. This is really 215 million, and I don't want to put 215,000,000. So what can we say here? In millions of dollars. Mm-hmm. Okay, so you take your time, you write down two very clear, well-defined variables. And then we move on to B. It says the breathalyzer sales information provides us with two ordered pairs. Let's write down the coordinates of those two ordered pairs. Remember, first one is time. I've got stuff circled in red for the first point. What's the time? So I could put 2009, but according to my definition, we're going time since the year 2000. So how long has it been since 2000 to get to this red point? It has been 9 years, comma. And then the y coordinate is the dependent, which is the value in millions of dollars. What is it for that red point? 215. And you don't need to put 6 zeros after that number because we chose to define things in millions. So we got a nice friendly point because we made some good choices here. 9 and 215. Okay, and then we've got the purple stuff that's circled. So the first thing I see is a 28. And then the second thing I see is a 2005. Is this right? No, you can't necessarily read things in the order it appears. The x coordinate is always time. So what is that in this case? 5, comma, and then 28 is good. And some students misread this and they think it's like up 28 and they start like adding 28 to 215 or subtracting 28 from 215. That's not what it says. You just got to read very carefully. Up from 28 million. It was 28 million. It'd be different if it said up 28 million. So just read carefully. Okay. And look, I've got 2 points, and finding the equation of a line connecting 2 points is the same fundamental process we followed in that quick check earlier today. So let's give it a shot. Part C says, write the equation of the line. I realized I forgot to do something up here. We defined variables without actually using any variables. So I think we've been calling them X and Y, but I didn't actually say that up here. So let's squeeze that in here. Let X equal, let Y equal. Okay, write the equation of the line that contains these 2 points. Great, we can now completely forget about the context of this problem. We have translated all of that gobbledygook up above into 2 points, and I'm really comfortable finding lines when I have 2 points. So the first step is to, oh, actually the first step we had the other in the process before was to circle the coordinates of one of the points. Makes no difference which one you pick. 5 and 28 are smaller than 9 and 215. I'm just going to pick that one, but you circle the coordinates of either point. So let's all circle that one. Step number 2, I'm just going to remind us of the process again. It's written out on page 47. Step number 2 was to find the slope. In the problem we did earlier today, we used some information about perpendicular slopes, right? Opposite reciprocals, but that's not what's going on here. We just have 2 points. And to find the slope when you have 2 points, we're doing that formula, change in y over change in x. Remember that one? y2 minus y1 over x2 minus x1. Okay, so we're supposed to subtract the y's over subtract the x's. So let's subtract the y's. 215 minus 28 over, what do we put downstairs? 9 minus 5. Just make sure you subtract in a consistent order, top and bottom. Okay, so we do the subtraction here. 15, is that 187? Over 4. Yes or no? 15. That's right, okay. Oh yeah, not reducible. So I know I almost always say I prefer fractions to decimals, but if we have a word problem, I think I said the other day, I think decimals are oftentimes easier to interpret. And it happens that we get a terminating decimal, so this one's not so bad. What do we get here? 4, 7, 5. Great. 42.75. 6.75. Okay, so we've got our slope. And then the very next step in our process from earlier today was to just plain write y equals mx plus b. We can write that. And then the next step was to copy that entire green equation. But what letter are we changing according to what we just found? M, right? We know M is 46.75. So you copy everything else, but just change the M. And this was the equation that gets the star. We're going to come back to that guy. The very last line is just going to be recopying that equation once we figured out B, but there's still a little bit of work to do to find B. So then we copy that equation, but we get to change X and Y into the coordinates of the point that we circled. We happen to circle the right one. You could perfectly well pick the left one. So 5 and 28. So this Y becomes 28. Equals 46.75 times X becomes 5. Plus B becomes B. That's what we're after. Okay, 28 equals. All right, somebody with a calculator help us out here. Okay, 233.75. And then to solve for B, what are we doing to both sides? Subtract that 233.75. What do we get there? Negative 205.75. Okay, so that one's B. And remember, the last thing is to just go back to that starred equation and change the B. That's it. So Y equals 46.75X, and then instead of plus B, okay. Okay, so that was exactly the same process we followed from earlier today for finding the equation of a line. I know I sound like a broken record, but this is a fundamental intermediate algebra process. Hopefully it was a little bit smoother this time, second time around. It didn't hurt that we didn't have any fractions to deal with here. Decimals are typically easier for folks than fractions. Okay, so there's our equation. Part D says interpret the meaning of the slope in this context. So that means we're going to write a sentence, try to explain in plain English what that slope means. Okay, the slope up here, we found it, right? It's 46.75. In order to interpret anything, I need units. I can't understand what that 46.75 is without knowing the units. Yeah, let's look at the units on the top first. I did 215 and 28. What were they measured in? It was millions of dollars, right? 215 million and 28 million. And so this 187 must be millions of dollars. And in fact, that 46.75 must be millions of dollars. And then per, even though there's a fraction here, it came from a fraction. So I'm going to force a fraction back. 9 and 5, what were they measured in? Years, right? It was 2009 and 2005. And when I subtract them, subtract 2 years, you're going to get a year. And so that's 46.75 million. And then a really important translation, instead of the division line, what word do we use? Per. $46.75 million per year. The sentence is almost already written just by getting the units in there and using the word per. So all we have to do is pad with a couple more words. The personal breathalyzer market was changing by $46.75 million per year. That's a full credit sentence. I'm going to be a little more precise. Instead of the word changing, is it increasing or is it decreasing by 46.75? Increasing, because that 46.75 is what kind of a number? Positive, that's right. If it had been negative 46.75, that would represent a decrease. But this is positive, so it's an increase. So we'll write our sentence. The breathalyzer market increased by $46.75 million per year. Questions on that? Okay, and then finally part E says predict the value of personal breathalyzers that will be sold in 2015 and interpret your solution by writing a complete sentence. So I've got our fancy equation that we worked so hard to build right there in green, top right. That's the equation that relates the year to the value of the personal breathalyzer market. So we just have to substitute. This 2015 needs to get replaced. It needs to replace one of these letters up here in this equation. Yeah, so we know that X is the time in years since 2000. Don't put 2015 for X. What are we putting for X? 15 years since 2000. So this guy becomes X equals 15. And so then we just copy that green equation. I'll move this green up in just a second. So 46.75 times, instead of X, what are we putting? 15, and then minus the 205.75. So just copy that equation, change X to 15. And somebody with a calculator help us out here. Okay, so we just have to write our sentence. That's 495.5 what? $million, right? And it's supposed to represent the value of the market in 2015. Can we say concretely the value will be 495.5 million? No, this is just our prediction, right? We're assuming everything is linear, then yes, this is right. But we should get the word predict in there. Something like our model predicts the value of the market was $495.5 million in 2015. Predicts the value of the market, say, what will be?
I said should be. The value of the first line should be 495.
Yeah, should be is good. What did you say, Sherry Ann? Same thing. Yep, should be, will be. I put was because 2015 is in the past now. And yeah, now it is. Okay. All right, so we did things a little bit out of order today. So what you're going to do is not the very next page, which is the start of these activities, but you're going to go back to wherever you left off in activities for lesson 8, which probably was page 63 or 60, 64 or 65. So I'm guessing most of us are wrapping up 64, starting 65. So work through all those activities. When you're done, move on to the activities here on page 70. I will walk around.